how are you? Hope you're having an amazing day today. Without wasting time, let's move to our subject matter. Today we are going to focus on thermodynamics. Thermodynamics is a branch of chemistry that deals with the different form of energy associated with the systems and their qualitative and quantitative relationship is called thermodynamics. It's a very simple definition. What is thermodynamics? You can define it. I hope terms involved in thermodynamics. First is system. What is system? Or substance, usually gas under study. You can imagine gas cylinder. Inside the gas cylinder, you there is a LPG gas. The LPG gas is system. Inside pressure cooker, we used to cook rice and dal. These substances are also systems. What is boundary? Usually boundary are wall, usually real or imaginary enclosing systems. What is wall? Usually real or imaginary enclosing systems. What is surrounding? Anything that lies outside of a system and surrounding. Okay, system plus surrounding plus boundary constitute a universe. Okay, you can understand this from this figure. This is cylinder and above this is a pistons, above this is a pistons, this is pistons. Okay, these are walls under these systems. Okay, everything outside is surroundings. Okay, up to this point you know what is systems and what is surroundings and what is boundary. I hope so. Now, types of systems. Types of system. Open systems: the system which can exchange its matter and energy with surrounding is called open system. You can imagine hot cup of tea. It can exchange heat and matter. Closed systems. Such systems can only exchange energy. Example, water in a hot conducting bottle. Another one is isolated systems. Isolated systems. The system neither exchange energy nor matter. Example, thermos. What is process? You need to know what is process. You need to know what is process. Thermodynamic systems. Thermodynamic systems goes from one state to another state through through a process. It can be defined as a sequence of steps or series of steps for state change is called thermodynamic process. Thermodynamic process are also of different type. Now, isothermal process, the process which occurs at constant temperature. Isobaric process, the pressure which occurs at constant pressure. Isochoric process which occurs at constant volume. Adiabatic process which occurs at constant energy. And cyclic process are such processes which have constant state functions. Okay, iso iso means same, thermal means related to temperature, means at constant temperature. Iso means same, baric means what do you understands by baric? Barometer measures pressure, therefore isobaric means at constant pressure. Okay, this is how you can mog it. Okay, you can याद गर्न सक्छौ. Equilibrium and non-equilibrium. A system can be called equilibrium or non-equilibrium if it satisfies following criteria. If it flows if it flows mechanical equilibrium, thermal equilibrium, and chemical equilibrium. For a system to be in a mechanical equilibrium, every part of the system should have same pressure, and systems to be in thermal equilibrium, every part of systems must have same temperature. And to be chemical equilibrium, every system must have same compositions throughout the systems. If a system follows this, then you can say this system's equilibrium balanced. Otherwise, these systems is called non-equilibrium. Okay, extensive property. What is extensive property? Property depending on amount, means property of thermodynamic systems which depends on amount. Example, number of moles mass, volume, gives free energy, Helmholtz energy, entropy, and enthalpy and energy. Where n represents, it can be repeated as nmb gas energy, n represents number of moles, m represents mass, b represents volumes, g represents gives free energy, a represents Helmholtz energy, s represents enthalpy, H represents entropy, and energy represents energy. And intensive property depending upon concentration. Example: temperature, pressure, density. Okay, how can you mug it? Extensive. You can take extensive, and depending on amount, it becomes exam. You can trick it. Exam. Extensive property depend on amount, and you can mock some examples like NMB gas energy. Okay, you can understand this way. Okay, and another is intensive property. Another one is intensive property. Intensive property, the property which depends on concentration of systems, like concentrations of substance. How do you mock it? In co intensive property depend on concentration. This is how you also mock it. What is, now you need to know what is reversible process. A process which occurs through infinite number of steps, and every steps are very slow and reversible to each other, then such process is called reversible process. Then such process is called reversible process. Such process can proceed bidirectional, forward and backward. If system such systems takes infinite time to complete. Such systems take infinite time to complete, and it can proceed forward and backward. यदि if if any systems which does not flow this criteria, then such system is called irreversible process. What is called irreversible process? You need to understand, you need to know how reversible process occurs. Just like initially, this is initial state where internal and external and internal pressures 2020. If external pressure 20 is dropped by 1 and it becomes 90, then internal pressure becomes 20. Now internal pressure becomes bigger than external pressure, and therefore system expands and becomes internal and external pressure 2020, and state 2, in state 2 internal and external 19. Now external pressure is dropped to 16, but internal pressure is 19. So internal pressure is greater than external pressure, therefore system expands by internal pressure till internal pressure becomes 16. This is how the system expands. Okay, now you understand what is, how does reversible process occurs. But irreversible process occurs at once. If system has if system's internal energy has 16 and external pressure has 16, now external pressure drops to directly 5 and internal pressure becomes 16, and internal pressure is greater than external pressure, therefore the system expands until internal pressure becomes 5. Okay, now you understand. State function. What is a state function? What is state function? State function is such thermodynamic property which depends on state of a system rather than how change is bring in a system. Example: enthalpy, another is entropy. Such property do not depend on how change is brought. If system returns to initial state through a series of change, then such state function of is called, then such state function does not change. Means if a systems if a system undergoes change of state from state A to B, either path A, either path 1, or either path 1, either path 2, either path 3, change in state function is same. That is, if we take state function as enthalpy of system at state A at state B is just to now change in enthalpy is equals to del S no matter how it is brought to be. Now, state of a system. You need to know what is state of system. State of a thermodynamic system depends on some variables like temperature, pressure, volume, and mass and compositions of system. Change in these properties or variables changes the state of a system. Their dynamic system state depends on these properties. If a system has constant mass, then state of systems depends on temperature, pressures, and volume. Temperature, pressure, and volumes depends on temperature, pressure, and volumes. If 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 you have only temperature and pressure, then you can temperature and pressure, then you can determine the state of systems without knowing volume. Therefore, temperature and pressure is called independent variables. What we call independent variables or parameters. This is called why? Because volume of a system can be determined if you know temperature and pressure. Therefore, volume is called dependent variable and temperature pressure is called independent variable. Independent variable. Look, system is in initial state here. System is in initial state here, has variables T1, pressure T1, temperature T1, pressure P1, volume B1. If undergoes pressure change, temperature and volume remains same and pressure change, it undergoes this state. When volume change, it undergoes this state. When it undergoes temperature, it undergoes this state. This is how change in variable change state of systems. Okay, now we need to know what is first law of thermodynamics. What is first law of thermodynamics? First law of thermodynamics is based on conservation of energy. It means that energy of universe remains constant. Energy of universe remains constant. It can be defined as in energy neither be created nor be destroyed, but it can be transformed from one form to another form in equivalent amount. Okay, let's illustrate first law of thermodynamics. Like systems, this is systems state state 1 where variables are p1, b1, t1. When it is given q heat, then it undergoes to state second where its variables are p2, b2, and t2. Now, let us consider q amount of energy is given to systems at state 1, then it expands to state second. It is it is quite obvious that certain amount of energy is used to change internal energy, and rest of rest of q is used to do expansion work. Rest of is used to do expansion work. Rest of is used to do expansion work. Okay, now first law of thermodynamics, we know that first law of thermodynamics tells that energy neither be created nor be destroyed, but it can be transformed from one form to another form in equivalent amount. Since we have given q amount of energy to system, it is quite obvious that some energy is used to change internal energy, which is written as change in du, and some energy is used to do work, which is represented by change in work. Okay, change in work. Now now we need to know some sign convention we used in thermodynamics. If you give heat, means if you add heat to a system, then if you give heat or add heat to a system, then it is given positive sign. If you remove heat from systems, if system lose heat, then it is represented by minus sign. if work is done, just look at this arrow. If work is done on the system, then it is taken as positive. If work is done by system, then it is what then it is given as negative sign. This is because why in chemistry, sorry, chemist wants to study these systems, okay. Chemistry wants to study these systems, okay. Wants to study these systems, and they focus on internal energy of the systems. If you give energy to the system, then internal energy of system obviously increase. If you remove some heat from system, then internal energy of system obviously decrease, therefore it gives a negative sign. If work is done on the system, then some potential energy is stored, in a system, then such work done is called positive work done. If work is done by the system, some energy of system is used in doing work, therefore such work done is given negative signs. I hope now you understand it. First, write first law of first law expression in different processes. This condition is given that if q amount of energy is given to the systems and it expands, then q in isothermal process expand and it expands, then q in isothermal process. We know that since we know that given heat q is given heat q according to the first law of thermodynamics is equals to change in internal energy plus change in work done change in work done change in work done, okay. Therefore q can be written as 0 plus minus change in work done. How? Since internal energy depends on temperature. Therefore change in temperature becomes 0 in internal energy, and therefore change in internal energy also becomes 0. Now therefore change in internal energy becomes 0, where change in work done becomes minus. It takes minus signs. Why? Because work is done by the system, because system is using its some energy, therefore we give negative signs. In isothermal process, total energy you give to the systems is used in doing work, is used in doing expansion work, okay. Now you understand isobaric process. What is isobaric process? In isobaric process, pressure remains constant. Since we know that this is the first law of thermodynamic expressions, okay, we can manage this, we can rearrange this, we can modify these equations as given heat is equals to change in internal energy plus pdv, because thermodynamic work done is equals to pdv. Since we know that if in isobaric process some internal energy changes, that internal energy changes is its nature is positive, and work done by the system, since gas is expanding, therefore we have given work done negative signs. Now therefore it becomes minus pdv, okay, minus pdv. Now you understand, this is expression of first law of thermodynamics in isobaric process. Now in isochoric process change in volume dv equals to 0, therefore work done pdv terms become 0, or pdv terms become 0. Therefore 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 total energy given to the systems doing is used in increasing internal energy, is doing internal energy of the system. Now you can write it, okay. Now you can write it this way. Now you need to know another property of thermodynamic systems, or another thermodynamic functions. Enthalpy, it is indicated by letter as it is it is it is the total heat content of the system. What is it? Is the total heat content of the system. It is the total heat content of the systems. Now it is mathematically represented as. Now enthalpy at final state equals to total energy at final state plus P2 V2. At initial state it can be written as H1 equals to E1 plus P1 B1. Now you subtract this equation, you get change in enthalpy equals to change in internal energy plus P2 V2 minus P1 B1. This is the actual expressions of enthalpy. Now you look that you see that what is total heat content, internal energy plus PV is total heat content. Now this expression, now this enthalpy expressions, now this enthalpy expression in case of in case of eight constant pressure, what let me, since we know that del is equal to change in internal energy plus P2 B2 P1 B1. Since when P2 is equals to P1, let this P2 equal to P1 equal to P. Now in these expressions, P is you can take P as a common, and therefore P times P2 B2 P my P P times B2 minus B1, and this B2 minus B1 you can write as a change in volume, which is dB delta V. This is the expression, okay? Change in enthalpy equal to change in internal energy, P times change in volume. This is the expressions of enthalpy at constant pressures, or you can say at constant temperature and pressure. Now enthalpy change 8 constant volume. Now enthalpy change 8 constant volume. It's constant change in constant volume. This is the expressions for enthalpy. When volume is constant, you can write this expression, but this term becomes zero. Why? When volume of gas is fixed, there is no gas does not expand from one state to another state. It means that there is no expansion work done, therefore the term becomes zero. Therefore in case of constant volume or constant volume and temperature, total heat content of system becomes change in internal energy of the systems. 8 constant temperature from ideal gas equation, P2 B2 is can be written as N2 R2 and P1 B1 equals to N1 times RT. And now from enthalpy equations, since in enthalpy equations we have PV terms, therefore S2 can be written as E2 plus N2 R2, and S1 can be written as E1 plus N1 R2. Now subtract this equation, now you get change in enthalpy equals change in internal energy plus change in number of moles of systems times RT. This is also one of the important equations you need to mark, okay? Now we need to calculate of phase transition. Phase means its state, whether it is in solid state or gaseous state or liquid state, okay? Enthalpy of fusion, first example is enthalpy of fusion. Enthalpy change take place when 1 mole of solid is converted into 1 mole of liquid. 1 mole of liquid, I know, 1 mole of liquid, it is called enthalpy of fusion. Similarly, enthalpy of vaporizations, enthalpy change when 1 mole of liquid is converted into vapor. Similarly, you can define enthalpy of sublimation. Enthalpy change when 1 mole of solid is directly converted into 1 mole of gas. 1 mole of gas. 1 mole of gas. Now enthalpy of reactions. Enthalpy change also take place in reactions, like enthalpy of neutralizing. Enthalpy of neutralization or neutralizing is enthalpy change take place when 1 gram equivalent of acid is being neutralized by 1 gram equivalent of base, and vice versa. Let's take strong acid and base Ha, and acid Ha and base BOS, and it undergoes reaction and forms water and Ba. This also can be written as H plus A minus plus B plus OH, okay? Now yes, proton and hydroxide combines and forms water, whereas A and B become can be written as this. On either side of these equations, these A and B are common, and B are common, this, so we can eliminate from these equations and can write as proton plus hydroxide equals to giving water. From this it is quite clear that Enthalpy of neutralization is actually formation of water from 1 gram equivalent of proton and 1 gram equivalent of hydroxide and forming water. In most of cases of strong acid and base, the enthalpy of neutralizations has been found to be equal to 13.6 unit when neutralizing acid and bases are different. One is strong, another is weak. Then in this scenario, enthalpy of neutralization is not equal to minus 13.6 unit. 13.6 unit. This is because some of the energy is used to ionize weak acid. Weak acid, you know that weak acid does not completely ionize in reactions or in solutions. But strong acid base ionize completely at dilutions. Now enthalpy of combustion. What is enthalpy of combustion? Enthalpy change take place when 1 mole of substance is completely oxidized or bond by excess of oxygens. Enthalpy of combustion is used to calculate calorific value or energy value of food. Calorific value of food is defined as amount of energy released when 1 gram of food is completely burnt or oxidized by excess of oxygens. Now we take an ideal molecule whose whose uh, whose molecular formula is CnS2n plus 2, which is being oxidized or burnt with oxygen on 3n plus 1 by 2 moles of oxygens, which gives n molecules of CO2 and n plus 1 molecules of water. Let the enthalpy change equal to ds, and we don't know what is the amount of energy released. We call that amount of unknown amount of energy x. Okay, now another important enthalpy change is enthalpy of formations. Another is enthalpy of formations. Enthalpy change take place when reactants in amount indicated by balanced chemical equations reacts to form 1 mole of substance. 1 mole of substance. Example, formation of carbon dioxide. Example, formations of carbon dioxide. His law. His law. What is Hess law? This is another law which is based on conservations of energy. Conservations of energy. This law states that heat of reactions or process is a constant quantity no matter it occurs in a single step or multiple step. This can be illustrated by following examples. We take formations of carbon dioxide. When carbon reacts with 1 mole of oxygen, it forms 1 mole of carbon dioxide. In this process, it gives minus 94 kilocalorie energy, and 94 unit energy. But when it is formed into a step, it gives different amount of energy, but total amount of energy also equals to 94 kilocalorie. This proves the Hess law of constant heat summations. In first step we form carbon monoxide by reacting 1 mole of carbon with half mole of oxygen. It forms carbon monoxide, and this 1 mole of carbon monoxide react with half moles of oxygen, and it forms carbon dioxide. In first step it gives minus 26 unit energy, and in second state it gives 68 unit energy. 68 unit energy, and this equals to 94 unit energy. And from this is experimental data. Therefore, this data proves the Hess law of constant heat summation. Just some few application of Hess law. This law is used to determine heat of formations and heat of reactions, and you can write a heat of transition, and another thing you can add there. Okay. What is bone or bone enthalpy? We know that it is quite obvious that bone formation requires energy. Bone formation requires energy, whereas bone breaking produce energy. It means that while forming bone, you need to bring atoms close. It means that you need to do some work. Okay, therefore bone formation requires energy, whereas bone breaking produce energy. It means that these two processes are different. If you need to bring atoms close, it requires energy, and if you need to take these atoms away from each other, then you need to then energy, the energy stored in forming process is released. It's that simple. it means that bone it means that it means that bone breaking is exothermic process, whereas bone formation is exothermic process. Bone energy or bone enthalpy, average of all bones dissociation energy, is called bone energy. It is average of all bone dissociation energy is called bone energy or bone enthalpy. Example: water bone energy. Water has two oxygen and hydrogen bonds. Let in breaking, this one bonds requires a amount of energy, and it requires a amount of energy, where another OH bond breaking requires B amount of energy. Now average means A plus B by 2. This is the bond dissociation energy. This is the bond dissociation energy. Okay, what is this? This is bond dissociation energy. Bond dissociation energy. Average of bonds dissociation energy is bone energy. Bone energy depends on electronegativity difference. Electronegativity difference increase bone strength. What? Electronegativity difference increase bone strength, therefore bone energy also increases. Another important quantity a factor is bone order. Bone order means number of bones. If the number of bones increases, then it is quite obvious that bone energy also increases. To break a single bone requires x amount of energy. It means that breaking two energy obviously requires x plus y amount of energy, and breaking three bones it requires x plus y plus z energy. Therefore, if bone order means number of bone increases, bone energy also increases. Another important factor, bone energy inversely proportional to the bone length. BL, bone length. If bone length increases, bone strength decreases. Therefore bone energy also, it means that you can understand what am I saying. This bone energy and bone length are inversely proportional to each other. If bone length increases, bone strength decreases. It means that small amount of bone energy is required to break. Therefore bone energy and bone length have inverse relationship. It means that they have inverse relationship. Derived thermodynamic work done. How do derived thermodynamic work done? Okay, there are multiple way deriving thermodynamic work done, but here is simple one. Simple method. Since work done is equals to F into D, where F is force required to move a body by 1 centimeter by 1 unit distance, where D is a distance. Therefore work done in moving body from one point to another point is F into D. Since we know that pressures is equals to what is force per unit area. Now you can rearrange these equations into this. Therefore force becomes pressure times area. Now work done equals to P times A times D. That is, it sounds like PAD, pad, where D is height of a cylinder up to gas is filled, up to which gas is filled, or area of cylinder. Now we know that area times height equals to volume. Okay, since it is quite clear that it is very basic maths. Okay. Now it looks like thermodynamic work done equals to F into D equals to PV. Since late at final state work done W2 equals to P2 V2 and initial state W1 equals to P1 V1, subtract these equations, it becomes change in work done equals to P2 V2 minus P1 V1. When this process, when the expansion process takes place at a constant pressure, then this in this scenario, you can write the P2 equals to P1, and it can write as a constant quantity, P. Therefore you can therefore you can write you can take P as a common and write this, and finally it becomes P times dV. Then it becomes P times dV. Okay, this is how you can derive thermodynamic work done. If you have any queries, you can ask me by direct message. You can by direct message. I will try to give your I will try to quench your thirst. See you.